This is the first XRT Manganese Production plant in the smaller size fraction of +10 to -45. Let's look at the commissioning phase. Looking at the size fraction, it was apparent from the beginning that there would be challenges within the size range, as there is no fine material in a lumpy size range. Hence the fact that the feed preparation has to be accurate and on target. Since the commissioning date, as stated above, we've processed around 8,000 tons through the plant, produced around 5,600 tons of actual sellable product at a feed rate of 60 to 80 tons per hour depending on the size fraction. That will give you around 26,000 tons per month or 6,500 tons per week. This can be increased to around 35,000 tons per month with the right size fraction, and with the second machine up to 70,000 tons per month. We achieved an average grade of 31% plus on the manganese side and a metal content of plus 52% on the overall metal content of the product. We are ready for a second shift. The out of spec material of +1 to -45 proved to be a challenge through the rainy season by creating a lot of mud that dropped the grade, which we had to get rid of. Once proper screening was introduced, this problem was resolved and allowed us to increase the feed rate. On this table we can see that there was an increase in the manganese percentage from around 24 to 32% in various samples taken throughout the commissioning phase. The out of spec material of +1 to -45 proved to be fine during the dry season, but also indicated problem during the wet season when the mud started creating between the larger particles that would then drop the grade during sampling. This image shows clearly how the team managed to adapt the process and the system to remove the fine -10 material and give you a product that is sellable and looks like the images as you can see above. As the plant was not designed to handle the -10 material, the team got together and changed the process, adapted the system and the flow of material to ensure that we can take the sandy material and turn it into a product as can be seen above, to make sure that the sellable product falls within the required spec and required grade. The feeding system takes the dry material and presents it to the scanner bars for injection. Over here we can hear the air blast ejecting the waste material into a separate part of the machine. Over here we can see that it's crucial for the system to have individual particles separated from each other to ensure that we can identify the waste product and inject it into a separate part, which then separates your waste from your product material. When water gets added to the -10 material, it creates mud between each particle, which then allows the particles to stick to each other, and during the sampling phase it'll ensure that the grade drops to a lower level due to the mud content of the sample and not a clean product sample. Again, the ARS team got together and resolved this problem by allowing the material to dry for a certain period of time and then feeding it back through the system to make sure that we can remove the mud and or the dust around the particles. Over here we can see what happens when the wet and muddy material gets passed through the system. It creates and blocks the system and also ensures that we don't get a proper grade due to the particles not being separated. The mud created around a particle also has a drastic effect on the feed rate and drops the feed rate of the plant on an hourly basis. These images clearly shows what happens to the ROM once water is added to the system. The material dries and creates a muddy substance between each particle. This needs to be cleaned and rubbed off to allow the system to still produce a product that is sellable and within spec. Daily reports from the mine indicated the problem and how the ARS team managed to resolve the issues. Once ARS resolved the issues of the smaller size fraction, the commissioning phase could continue with the right product.
Just to show you the waste that's coming out so you can see the waste pieces and the really low grade. It's quite clear to see how it kicks out all of this low grade stuff on the waste side.
The waste separation and the product, as can be seen above, clearly shows what's the capability of the plant by producing a sellable product. The ARS team assessed the challenges and within a couple of days managed to come up with solutions to ensure that we can handle damp material, remove the mud and or excess small size fractions, and remove the dust at the same time. This allowed the plant through different stages of around 20 critical areas to ensure that the process of the material through the plant will provide a sellable product at the end of the day. The ability of the ARS team as a whole to adapt to different conditions clearly shows how we can work as a team, whether on-site or off-site, to come up with solutions. As you would see in the next image, we added various different unique solutions to ensure that we can deliver a product that wasn't possible in the past by removing the sand and the dust to make sure that the grade is met.
Okay, now this is one of the other piles. The material looks as clean, but if I open it up here, there's nothing inside here. It just keeps running. The material just keeps running because there's no binding on the inside. The product is so clean.
The clean product, as can be seen in the images above, shows that the solutions that was added to the ARS plant clearly works and will ensure that the plant will deliver high grade and at high feed rates. ARS is now ready to go into full production on a dual shift basis to ensure a proper product of high grade, high volume and continuous operations.